Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour to an hour and a half with questions throughout, and I'll now turn it over to the speaker for introductions.
Okay, thank you. So my name is Ron Sumida, and I'll be conducting this session. And just to give you a little bit of information about my background. So I've been working with Microsoft technologies now for over 25 years. Started all the way back in 16-bit Windows doing user interface programming, and have stayed with the Microsoft stack of technologies ever since. So all through the various eras of Microsoft technologies. Been working a lot lately with .NET 6 to give you an idea of how I followed the progression of Microsoft software development. And then have been working a lot with open source in the last 7 to 8 years in particular, and have been doing a lot of Azure since about 2018. And in the last about year or so, have been doing a lot of work with Docker and Kubernetes. And the reason why I bring that up is that's a good segue into this session and what we're going to cover in here. So while this is titled DevOps Tools of the Trade, the example we're going to be using is one of taking a Docker Kubernetes app and deploying it out there and using some form of a DevOps type pipeline in order to automate the process of CI/CD. So that's the quick summary of what this entire session is really about. More specifically, we're going to talk about implementing DevOps in cloud-native application scenarios. We'll look at building and deploying infrastructure apps. And as I just mentioned, Docker and Kubernetes is the example we're going to use here. If you don't know a lot of Docker and Kubernetes coming into this session, don't worry, because it doesn't assume a huge amount of knowledge of that. But for those of you who are familiar with it, you'll recognize elements of both of those technologies in the examples we're going to be using here. But the main focus is going to be on these two items, GitHub Actions and Azure Pipelines. So that's the part that I really want to spend the time on. I'm not going to spend too much time talking about the specifics of the example application that we're going to be using, which is Docker Kubernetes apps. But if you do know a little bit about that, it helps. It helps to understand the example a little bit more thoroughly. The objectives of this session are, first of all, to describe the principles of DevOps. I'll do that at the beginning so that you know some of the terms, definitions that are important in this space. We'll look at implementation in cloud-native scenarios in particular. We'll talk about implementing DevOps principles, and I'm going to do demos of both using GitHub and Azure DevOps. They are very similar in terms of what they do and the way that they do it is a bit different, but ultimately how they get to the same place, they get to the same place in many respects. If you're wondering about the differences between the two, I will cover that at the end of the session, because there are some functional differences, although by and large, they accomplish basically the same thing as I was just mentioning. We'll look at how to build and deploy infrastructure apps using GitHub and DevOps as well, GitHub Actions in particular, and Azure DevOps. So what do these offer? Why look to use these to begin with? Well, you want to be able to incorporate into your development process, number one, automation. And number two, you'd like to be able to have a wide range of tests and feedback loops, ideally. And the benefits of doing it this way are it helps address the complexity of deployment. If you look at software development, and I mentioned how far I go back with the Microsoft stack of technologies in particular. I mean, I can think back to the days when I first started programming on Windows 3.1, and first Microsoft technology I worked with a C-based API, not even C++, C-based Win16 API. And you didn't have formal processes like this for doing development. And there was no such thing in those days that I recall as unit testing. You didn't have formalized processes for deployment the way we do today that are heavily automated. Basically, it was you created some sort of a zip file equivalent and handed that out, or an MSI, and people ran that. In fact, in the really early days, I remember software was distributed, like precursors to Visual Studio. Literally, they came on floppy drives. First class I ever taught, as a matter of fact, was like that. Everybody in the class went and installed this Visual C++ at the time on their machines, by using floppy drives. So that was the deployment scenario many years ago, but you could get away with that, right? Because Visual C++ fit on about maybe 6 floppy drives at the time, and the software was a whole lot simpler. But today you look at the complexity of modern software and you realize there needs to be some way to automate the process in a lot more formally, and also to minimize potential for downtime due to human error. As complexity rises, the likelihood that things go wrong rises as well. And so to address that, you want to have more formal processes for doing some of these steps of integration and deployment. And the benefit of this is it enables a consistent deployment across multiple environments as well. The prerequisites for this session, I talked a little bit about how having Docker Kubernetes knowledge is helpful, but certainly not essential. The parts that are most important coming into the session are, first of all, an understanding of cloud computing. Best case scenario is you've worked somewhat with Azure, but even if you've worked with some other cloud environment, like AWS, for example, that would benefit you because at least you'll know the basic cloud concepts. And familiarity, ideally with Azure, general software development concepts, and DevOps principles, although that last one on DevOps principles, like I said, I'm going to try as best I can, given our time constraints, to bootstrap everyone to tell you some of the general DevOps principles coming in the upcoming slides. Speaking of which, let's start with this. What is DevOps? There is a great talk that was given by a gentleman at Microsoft named Donovan Brown, who defines DevOps this way. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And I chose that quote to put on the slide because I think it's a great definition in that it's relatively compact, fits in about one sentence, and it also is great in that it's fairly comprehensive as to what the motivation behind DevOps is. If you want to watch the talk itself, I put a link to the YouTube page where you can watch one version of the talk that he gave. There was a period, my browser's up to date, browse YouTube. Oh, okay, that's just a thing. But in any case, I'll leave it up to you to hit that. And depending on how your setup is done, it may take you right to the video, but it's a great video. And he gave this talk in about 2017, 2018 timeframe. So parts of it are somewhat dated now, but the talk is called From Zero to DevOps. And basically what he does during the talk is he starts from nothing and goes all the way up to an app ready for production during the course of the talk using the Microsoft technologies. And of course, a big part of being able to make that happen is a DevOps type solution. And at the very beginning, he talks about what DevOps is and gives this definition. So if nothing else, it's worth watching that talk just because he's such a great speaker, but also because it's very relevant to what we're talking about in this particular slide and at the beginning of this session. All right. The back end of that, you may not care as much about watching in detail, largely because, like I say, it's pretty dated now. It was from that 2017, 2018 timeframe. And he gave the talk in a number of different locations. There's a number of different YouTube videos for that talk. So you may want to take a look at, various ones because they're all going to have the same content, but he delivers it a little bit differently each time. Basically, what DevOps is meant to do is to facilitate the convergence between development and operational practices, hence the name DevOps, right? Development and operations. And it's become the dominant trend in software lifecycle management. And it optimizes your software processes for development, deployment, and maintenance. So DevOps has become a really big discipline in its own right. And this is a relatively more recent, right? Again, if I go back 10 years or so, I don't remember people back then talking a lot about DevOps. But particularly in the last 5 years or so, this has really exploded as its own discipline. Here are the main DevOps components. Source control is one big aspect of it. That's been around for a long time. Source control, I do remember 10 years ago. There's continuous integration. In fact, 20 years ago, I remember people doing source control. There's continuous integration, which is also referred to as CI. There's continuous delivery, which is referred to as CD. And then there are CI/CD pipelines, which is what we will be discussing in this session. In fact, a big focus of what we will talk about here is those CI/CD pipelines. And one other acronym and term I'm going to throw at you is infrastructure as code, or IAC. right? And if you're relatively new to that term, don't worry, because I'm going to actually do a full-blown demo of infrastructure as code coming up. So let's break down what each one of these bits mean. So what is source control, also referred to as version control? I think you guys all already know this. It's the practice of tracking and managing changes to code. And you need some type of source control management system for this. Prime examples of which are, and this would be the number one thing I think most people these days think of when they think of source control, because it's become so dominant now, which is GitHub repositories. And if you were at my talk last night, I did talk about GitHub there somewhat. Didn't show much of the GitHub repos in detail. We're going to cover that a little bit more detail here. But also Azure DevOps has repositories as well. And I'm going to be showing you that toward the end of this session. Now, one aspect of what needs to be addressed when you deal with source control is conflict resolution. And this is a very important thing, especially given that you in modern software projects have multiple developers working on it who are in all likelihood working on parts of the project independently. Well, when you go to merge it together, how do you deal with potential conflicts between the various branches that the software developers are working on? And source control usually provides very nice ways of dealing with merge conflicts. Of course, you want the ability to collaborate. I was just referring to that a moment ago. And source control becomes an essential tool for a multi-developer project. And another very important aspect of what source control provides is a degree of separation to enable the creation of different independently tracked and maintained code repositories. So these are all some of the major features of source control. What is CI? In other words, continuous integration. That's the process of automating the build and testing of code. And ideally, every time an update is done, it's committed to the target repo. And this promotes frequent testing. In every class I teach, I always emphasize, independent of the technology these days, basically, the importance of unit testing. Everybody knows these days that they should be doing it. If they're not, and hopefully they're doing it actually, they're doing frequent unit testing, but you would ideally like your unit tests to be run in an automated way. I always emphasize the importance of that as well, particularly unit tests especially, as opposed to other forms of testing, which ideally also get run as automated as possible. But unit tests are vitally important that they be automated, largely because they're supposed to be run very frequently. And if they're not automated, developers won't be motivated to run them the way that they should. Now, what gets produced from CI is artifacts, which are testable and deployable software packages. And continuous delivery, the CD part of CI/CD, automates the delivery of the artifacts to the target environment. So these are some of the definitions of the terms that you should know going into this session. I mentioned the term pipelines a moment ago, now that we've discussed what CI/CD is. So what is a CI/CD pipeline in particular? This allows the creation of a well-defined structure that represents processes for building, testing, and deploying. And in particular, Azure Pipelines, which is what I'm going to conclude this session with, is a demo of Azure Pipelines, is such that the structure is divided into stages. Each stage consists of one or more jobs, and each job includes one or more tasks. GitHub Actions, which is another alternative to Azure Pipelines, which, as I talked about a few seconds ago, does a lot of the same things that Azure Pipelines do, consists of workflows that combine jobs and tasks, each of which performs an individual action. Now, I used this term a few moments ago as well, IAC, infrastructure as code. What does this refer to? Well, this applies DevOps principles to managing and maintaining services, which are traditionally the responsibility of infrastructure and platform teams. And these services serve as the basis for software deployment, right? Like compute, networking, and storage components, for example. And IAC has gained prominence with the advent of cloud technologies, since it eliminates dependency on physical on-prem infrastructures. This is one of the big changes that I've seen in the last about since 2017, 2018 or so, as the cloud has really exploded in popularity. I mean, cloud's been around a lot longer than that, of course, but I've seen an explosion in popularity of cloud-based services, particularly in the last 5 years. This is one of the things I love about having been in the training business all this time, is that it gives me a real sense of what technologies are hot and when they really have started to mushroom. For example, about 10 years ago, I saw everybody asking me to deliver the same 3 basic things, which told me that this technology was rising up. And those 3 things were unit testing, dependency injection, those all kind of rose up together in mocking. And seeing that everybody was asking me for those things all at the same time, this is literally about 10 years ago, that told me that unit testing had finally arrived to a level where people realize how important it is. And I would say about 5 years ago, just anecdotal personal experience, I started to see a lot of requests for cloud-based technology training. And that's what told me that the cloud had really arrived such that developers were very actively using it. And obviously those technologies were around well before 5 years ago, but I didn't see as much interest back in that period before then. But about 2017, 2018 or so, that was the time when I started to see a huge explosion of interest. And IAC uses automation to configure and control the infrastructure. That's the key word here, is automation. We want to be able to automatically, for example, and this is one of the demos that we're going to be doing, configure AKS clusters. AKS, if you don't know that, is Azure Kubernetes Service. So basically the short story there is that Microsoft does have up in Azure a service called Azure Kubernetes Service, or AKS, and they have the management of some of the Kubernetes infrastructure for you. Particularly, this relieves the developer of having to manage the clusters the way that they ordinarily would if they were not using AKS or some other cloud-based equivalent. All right, that's about all I'm going to say about that for right now. This talk is going to have some periods of dead time, by the way. What I mean by that is, since I am going to be doing demos of doing deployment, and some of the runs that I'm going to do are going to take about 5 minutes to complete, and I never like to have dead time. One of the things that I can do if there's interest, so I'll let you guys tell me via the chat whether you're interested in it and having me do this during the dead time. I can do a little bit of a primer on Docker and Kubernetes if you are new to it. So let me just ask this, and you guys can respond via the chat in StreamYard, whether you have any knowledge or background in Docker and Kubernetes, because as I've been telling you, the examples are going to involve that. And if you don't, in particular, it would be really good for me to know that, because that will give me an opportunity during those periods of dead time we'll have in this session for me to hopefully bootstrap you a little bit on what Docker and Kubernetes are about. There's a whole class that I teach and wrote from the ground up, actually, on Docker and Kubernetes. So I have plenty of material, more than enough material to fill up multiple sessions on those topics by themselves. All right. But in any case, this is the example we're going to be using, is literally automatically configuring AKS clusters so that we can deploy containerized applications. And just very briefly for right now, because I don't know whether we're going to actually end up doing that Docker Kubernetes sort of quick primer.
Sorry to interrupt. So we have a few people saying no Docker Kubernetes knowledge here. Yes, I'd like to learn more about Docker and Kubernetes. And then someone says same here.
Okay, great. All right. What I'll do then is during those periods of dead time, we'll go ahead and do that. Very briefly for right now, just so you, at least at a high level, know the concept of what containerized apps are about and Kubernetes is about. And then again, I'll explore it in more detail for the 5 or 10 minute periods we have, which are blackout periods while we're waiting for stuff to provision. A big trend now is to take your applications and containerize them. And the benefit of doing that is by containerizing, number one, you remove any platform or operating system or cloud-based dependencies. So if you look at the major software packages, libraries these days, they've largely been containerized. There's this entity called Docker Hub where you could look up, it's a whole big repository of containerized applications. And just about all the big names in computing technologies have containerized their apps and put up images. They're called images on Docker Hub. And the big benefit of doing this is, number one, it allows a way to share software across multiple parties independent of what they're running on. So, this old thing of, well, what if you're running on Linux? What if you're running on Windows? What if you're running on, and if you're running on Linux, which flavor of Linux, right? Are you running on Ubuntu? Are you running on Red Hat Enterprise Linux? There's all these different flavors of Linux. And you'd like to be able to share software across all those flavors as well as different operating systems. And then there's other issues like, what about different cloud vendors? Things work differently if, let's say you're doing microservices. If you're doing it with Azure, which uses Azure Functions, if you're doing it with AWS, which uses something called Lambdas, the details are different. High level, big picture is basically the same. But by containerizing your app first and then using Kubernetes very briefly is a container orchestrator. That's the quick, very simplistic summary of what it's about. It orchestrates the containers. And by doing that, it makes it so that everybody can effectively share and be able to run software that may have been developed on a completely different platform or cloud computing environment even, right? That's the very brief, like 2-minute summary of what it's about. Okay, here are the ways to implement IAC now. There's a declarative way and there's an imperative way. The declarative way is to define what the code should accomplish and not, very critically not, that's why I highlighted that both in italics and boldface type, the word not, how to achieve the result. And this uses tools like Azure Resource Manager or ARM templates. If you don't know what that is, depending on your experience with Azure, I'll just tell you very briefly. An ARM template allows you to take a resource in Azure and create it in an automated way. It's basically a template that you can run and therefore create a resource up in Azure with all of the right settings in place, but do it automated. That's as opposed to sitting in the Azure portal and selecting all the individual settings you want for that resource manually. And the benefit of using ARM templates is not just automation, but also repeatability. If you wanted to create, let's say, the same resource exactly the same way in multiple different Azure subscriptions, you can use an ARM template to accomplish that easily as opposed to having to go into each individual subscription and manually provision it. Imperative is another way to implement IAC, and that's to define what the code should accomplish. And so very key word there. That's why I both put it in italics and boldface type, how to achieve the result. So that's the distinction between the declarative and the imperative way is this second phrase, how to achieve the result. That is not the case in declarative, but is the case in imperative. And an example of imperative way to implement IAC is to use tools like PowerShell or the Azure CLI standing for Command Line Interface, or the SDK, right? Those would be imperative ways to implement it. By the way, we're going to use a mix. We will use the Azure command line. You'll see coming up in a more limited way. But the first demo I'm going to do, we're going to be using ARM templates. And you'll see an automated way to set up an AKS cluster. Which I got to talk about this before I can get into that first demo, which is GitHub Actions. So as I mentioned to you in the intro to this session, I'm going to be showing you two things. Number one, GitHub Actions. And number two, Azure DevOps pipelines. So let's talk about GitHub Actions first. This provides task automation and workflow functionality. It basically streamlines your software development lifecycle. It implements a CI/CD pipeline. And the way that GitHub Actions are specified is by using YAML. Now, I got to caution you if you've never touched YAML before. If you're wondering what YAML stands for, it's kind of humorous, actually. It stands for yet another markup language. And YAML is used in a number of different contexts, just so you're aware. But I will tell you, and a prime example of where YAML is used, by the way, is in Kubernetes. Kubernetes, you set up some of the resources there using YAML. From my experience with YAML, and I think anybody who's ever used it will tell you this, it is extremely picky about white space. It's one of the big caveats I give everybody when I introduce anything having to do with YAML, that the indentation really matters in YAML. If you get the indentation the slightest bit off, it fails when you go to use it. All right. So I got to caution you because I am going to be doing a demo coming up where I'm going to grab some YAML. And if you try to repeat the demo that I'm going to do, be very careful that you don't mess with white space or indentation. There are parts that you're going to need to change, and just change those parts, but do not modify anything else unnecessarily. Like, don't try to think that you can outsmart the samples that are given to you and come up with a better indentation than what they do, because that's going to matter. In most other technologies where you have some form of a markup language, white space usually doesn't matter. But in YAML, it is essential that you get white space exactly right. In fact, in the Docker Kubernetes course that I wrote, I do one lab where I make people type in a not too complicated, but complex enough bit of YAML just from scratch, just so that they have the experience of doing it once, so they can see how hard it is to get every white space and every detail of it exactly correct. And then after that, I tell them, look, you're never going to realistically type in YAML from scratch. Normally what you do is you get a sample that's similar to what you want to do and substitute the parts appropriately, because for more complex YAML files, it is very cumbersome to type it in from the beginning. All right. GitHub Actions can be used to implement Azure infrastructure components. So for example, we're going to be using ARM templates, and you can specify a trigger condition for running your workflows. So for example, what we're going to look, and we'll do this as a demo. When the developer commits a new version of the source into the repo branch, we want to be able to automatically rerun a set of actions. In fact, this is the core demo that I'm going to be doing, is exactly that. We want to be able to automate the setup of a build and deployment process. That's number one. Number two, we want to configure it such that if the developer comes in and makes a change to the source code somewhere, that automatically that process gets rerun. In other words, the developer doesn't have to do anything else to rerun it. It's all automated through the setup with GitHub Actions. So any change to anything in the source, i.e. the change to the repo, automatically triggers a rebuild and a redeployment with the latest changes. And if all goes well in the demos I'm going to do, you'll see that in action. So you see what we're shooting for. And this results in a reliable and sustainable build and deployment process. And keep in mind, as part of this process, it may not just be about getting a new deployment up. It's also one of the things you could put into the pipeline with GitHub Actions, and also Azure DevOps as well, is a rerun of your unit tests, right? Developer comes in, they change some aspect of the code. Well, something else you want to do, not just to rebuild and redeploy, but along the way, you want to rerun your unit tests, because that change the developer made could have caused some bad effect somewhere else. And you want to be able to know about that. So you want to automatically rerun your tests. And that can be put in as a portion of the whole pipeline, right? Is the run of the unit tests. All right, so this is the big demo. First of 3 demos I'm hoping to do depending on time. This one will get our feet wet in implementing IAC using GitHub Actions. We're going to test the concept of IAC in this demo. We'll use GitHub Actions to do that. We're going to deploy an ARM template. You'll see, if you've never seen an ARM template before, you'll see an example of one. That ARM template will provision an AKS cluster that's suitable for hosting a cloud-native app. Now, there's going to be a lot of steps, a lot of detail in this demo that's coming up. I don't want you to lose sight of the big picture, though. So once again, I'll reiterate what the big picture is before I jump into this demo. Because anytime I do something that's this long and this complicated in terms of number of steps, I always fear that along the way, people will just, their eyes will glaze over and they'll lose sight of what we're trying to do. What we're trying to do is to set up basically what was discussed here, CI/CD pipeline, so that we can automate the process of setting up an AKS cluster. And our longer term goal, it will be more in the second demo that we'll do this, where we can come in, make a change to the source code somewhere or to the markup files, and have that automatically trigger a rebuild and a redeployment. And we want to be able to see that that redeployment was successful, in that when we try running the app again, we see the change without us having to do anything other than just make one change to one file. It'll be a simple change, of course, but enough to illustrate the concept. If you want to try replicating what I'm about to do here, I put the link to the instruction page, the particular part of the instructions for the lab I'm about to demo to you right here. This is the first of the, it's really an exercise, but I'm going to do this exercise as a demo for implementing the infrastructure as code using GitHub Actions. So there is the link. And it explains to you in detail. So I'm just going to walk through this quickly. You guys can read it in greater depth and, like I said, replicate it on your own. But there's a few things I want to point out right at the beginning. What we're going to be doing is setting up a GitHub repo, preparing for the AKS deployment, and deploying an AKS cluster by using a GitHub workflow. And then ultimately, this is very important, by the way, if you ever go and try this on your own, delete the deployed resources when you are done. And I'll emphasize that right now because this has a cost implication. These Azure resources that we're creating in particular, especially AKS clusters, are expensive to keep around. All right. Some Azure resources are virtually free to keep around. In other words, you can have them sitting in your tenant and it's no big deal. For example, a B2C tenant, that you can keep laying around and there's no cost to it, basically. Other resources that are very expensive just to have it. For example, particularly when you do Azure infrastructure, like networking infrastructure, some of those components, I have seen literally, I used to teach an Azure infrastructure course, which was a lot about Azure networking and all of that. And I remember whenever I teach that class, I'd have to really remember as soon as I was done really done with a particular module, I would go in and delete everything I created, because if I left it laying around, I could lose a good portion of my $150 in Azure credits with my MSDN subscription for the month. And I didn't want to run out of credits. So AKS resources, by the way, are not anywhere near that expensive, but they're expensive enough that I'm going to caution you how important that last step is, right? So I'd be remiss if I didn't put particular emphasis on that. All right, here are the prerequisites. You need an Azure subscription. If you don't have one, by the way, you can get a free trial. There's a web page, you can Google for it and find it, for signing up for a free Azure subscription trial. You need a Microsoft account or an Azure Active Directory account with global admin access and in the Azure AD tenant associated with the Azure sub. And you'll need a GitHub account. And that one's easy. If you were at my talk yesterday, I talked about GitHub and how to sign up. If you were not at that talk yesterday, then just go to github.com and then click on the sign in link in the upper right corner and get a GitHub account, which you should have. If you're at this talk, chances are you're interested in playing around with these technologies. And one of the first steps in working with just about anything related to what I'm talking about here is you need a GitHub account. All right. So what we're going to do first is set up a GitHub repo. Since I have all these things all set up for myself personally, and again, you can look at other resources to find out how to get started with setting those up. I'm going to just start from my own GitHub repository. So this indicates that I'll start by creating a GitHub repo that's going to host the artifacts that are used to deploy the AKS cluster. And I'm going to go off to my GitHub page first. So when I go to github.com, since I already have a GitHub account, I've already signed up and signed in both. That's the reason why it takes me right to my GitHub account. And in particular, I'm going to go just not to this one. In fact, this is a demo that I'm going to hope to get to in this session. We'll see how time goes. But this is the top level of my GitHub account page. And then I can look at the repositories by clicking here under repositories. And then if I want to create a new repository, I can just click new there. And that's what we're going to do. First step, as you're seeing in the screenshot, is to get to where I just showed you a moment ago. So you can create a new repository. And we're going to set this name for the new repository, CNA-DevOps 03. I'm going to literally do exactly what this page tells me to do. All right. By the way, this page that I'm on right now, which has all these instructions that I'm demoing to you, very well done. They do a great job of explaining things. What's here is generally accurate and up to date with one exception. And when I reach that exception, I'll correct it along the way. There's one thing that's a little out of date, such that if you just try to march straight through and do the exercises here that I'm doing, you're going to get a failure along the way. But fortunately, I know exactly how to correct that, so I'll point that out when we reach that. All right. So that's good enough. We're going to create the repository. You can make one other change because it does tell you to use the private option. Right now, by default, public is selected. I'm going to switch that over to private. Everything else stays the same as the default. So I'm going to click create repository, and that will be our first step to get going. Now, the next thing I'm going to have to do is prepare for an AKS cluster deployment. So I need to add a secret to the repository that will allow us to provide GitHub Actions with access to your Azure subscription. Here's the story of what's going on there. We are going to have to, from the GitHub action that we're going to create, so from here, from GitHub, we are in turn going to access our Azure subscription, right? Those are two separate entities. One of the things you have to be really careful about whenever you're dealing with two separate entities, of course, is security, right? So in other words, how does the Azure subscription know that it's safe for a separate entity like a GitHub action to be able to access it? That's the purpose behind these next set of steps, all right? So if you go through and do this lab, make sure you don't skip this step, because if you do, you're going to get basically a security failure later on, not immediately. And that's why it's very important to remember to do this next piece that's very well outlined here. So to prepare for the AKS cluster deployment, you'll add a secret to the repository that allows you to provide GitHub Actions with access to your Azure sub. You'll also register for Microsoft Alert Management Azure Resource Provider, which is required to provision resources included in the deployment. So it says in the web browser, open another tab and navigate to the Azure portal and sign in. So I'm going to do that. In fact, I already have that up right here. I have a tab that is accessing my Azure subscription. It doesn't even have to be in another tab, by the way, in the same browser. You can open up another browser altogether. That's fine. They want you to go to the Cloud Shell, which is here. This is this button right here. And by the way, there's two different modes that you could be in when you're accessing that shell, either PowerShell or Bash. So notice on this drop down, the two different options. Make sure you're choosing Bash here. In other words, if PowerShell is showing up there like this, you'll want to, I'll go ahead and confirm for a second. This takes me into the PowerShell window. If it shows PowerShell there, then come back around, pull this down and switch to Bash, because that's important that you're in Bash as opposed to PowerShell. It's mentioned here, right here in step 4, but I just wanted to highlight that. All right. And then it mentions this is the first time using the Cloud Shell and you're presented with you have no storage mounted message. Select the Azure subscription you're using in this lab and select create storage. So here's a story of what that message means. The very first time in your subscription you're accessing the Cloud Shell, they have to create a storage resource to back it. And it's only the first time. Once that resource has been created, as long as you don't delete it, then when you come into the shell, it'll automatically see that resource is there and will automatically use it, right? So that's all that's going on there. Just be aware of that. In fact, this is how good these lab manual instructions are, that they even accounted for the scenario where somebody is brand new to this and they have to do that selection. Because I've done this so many times, that's why I don't have to do it, since I already have that Cloud Shell resource created. All right, so it says within the bash session in the Azure Cloud Shell pane, run the following commands. So I'm going to just go ahead and do that straight up. It does mention here, by the way, let me go back to this, that it says, run the following command to identify the subscription ID of your Azure subscription. That's the intent behind what we want to do. One thing that you should know when you come into the bash shell, as I'm doing now, and you have copy text into your clipboard and you want to paste it, a Control-V does not work. So you need to know that you'll need to right-click and choose paste manually. Even though Control-V normally works everywhere else, for some reason, it doesn't work in the bash shell, and I just know that from anecdotal experience, so you'll need to right-click and choose paste, and that always reliably works. And then what you want to do is record this, which is your subscription ID, all right? So I'm just going to grab that off and put it into a notepad file, since I'm going to need it, all right, like that. All right, okay. Next thing is this piece, and so it tells you to record it, so you probably want to put it in a notepad file or someplace where you can get to it in a few moments. It says within the bash session of the Azure Cloud Shell pane, run the following command. Now this command right here is going to set up a service principal, and I'm going to go ahead and run it. I've already run this before in the course of testing this lab. So for me, it's going to indicate that it's already been set up. But if you're doing this for the first time, like you would be, when you're trying this lab out on your own, you will not get that message. So I'll just go ahead and run it straight through. It does indicate here, creating control, where is it? Found an existing application instance of ... We will patch it. So basically that's what I was telling you about, that it did find some of the stuff from before. But if I run the second of the two commands, echo the service principal, which is what I'm looking for, then it does the right thing, right? So I'm going to grab all of this off. You want to grab the whole thing, copy that, and again, preserve it, because this is going to get placed in a spot for the infrastructure we're going to be setting up in a few moments. And that's about all you need to do in that bash shell. Now, the next thing is to switch back to the web browser where we have the GitHub repo and select the settings tab header. So I have to go back to the other web browser session that I had up, which was not there. Oh, I think it was. This is the problem when I open up too many tabs, that I have to go and find the right one now, the GitHub one right there. All right, and I'm going to go to settings, as it was indicating, and then from the settings page in the vertical menu, I'm looking for secrets. So the vertical menu on the left side, that implies left side, by the way. It's part of the reason I'm doing this demo, that while the instructions are very explicit, in some cases it helps to actually see it. And in this case, a little harder to find it. They did say vertical menu. That means left side. So when I expand out underneath secrets there, then I'm looking for the Actions Secrets page. So make sure you choose Actions underneath there. That takes you to the Actions Secrets page here. It says there are no secrets for this repository, but I'm going to look to create a new repository secret as indicated right there on that web page. So I'll click there, and then it'll tell me exactly in the instructions what to configure. So it says on the Action Secrets page, name the text and put the name for the name in the text box Azure credentials. So I'm going to do that. Grab that off, stick that right into here. And then in the value for the text box, that's the JSON representation that we got from the last bash shell command right here. That's where all of this gets used. Basically, all we're doing here is we're setting things up so that we created a service principal in Azure, and we are then putting that into GitHub so that now when GitHub tries to communicate with my Azure subscription, it will be able to successfully do that. That's what's happening. All right. So now I'm going to add the secret, and then we're good to go. Right. So now I'm going to switch to the web browser tab that displays the Azure portal with the bash shell. And within the bash session in the Azure Cloud Shell pane, run the following command to create the Azure resource group that will host the AKS cluster. All right. Now I want to say a note about this, that notice here for the location setting, they have that set to South Central US. If you're new to Azure, here's the best practice in terms of choosing a location. So you don't necessarily want to just blindly put in what they have there. My normal advice is to choose the location that is geographically closest to where you are, right? So if, for example, you are in Redmond, in the Redmond area, or on the West Coast, I would use West US there. If you're on the East Coast, I would use East US. Both of those data centers, from my experience in working with them, and because I travel so much, I've used both, because you generally follow that rule. I have had generally very few problems with either data center. South Central US, the one selected by default here, is one worth knowing about as well. It may be the case when you try to create a resource that data center that you have specified, even though it's geographically closest to where you are, may be overloaded at that moment in time, and you might not be able to create the resource you're looking for there. And by switching to a different data center, you may be able to create it. So what I found just from anecdotal experience is that South Central US is one of the best ones in terms of being lightly loaded in the event that you run into problems with the more local data center to where you are. And if you are in the South Central part of the US, then I would encourage you to just use that right out of the gate. I am in the Los Angeles area right now. So I will tell you that normally I would use West US, but because I know South Central US works well, and I'm not too concerned about cost because I know that I'm doing fine on my Azure quota for the month, I will go with that, right? I'm just going to take that default straight away and not worry about it otherwise. But again, best practice ordinarily, choose the one closest to where you are. Okay, so set location to take to their default value. I'm going to run AZ group create. All this does is creates what's called a resource group. The resource group in Azure is a place where you can put a bunch of different but related resources. And the benefit of using a resource group is that, remember what I talked about with the importance of deleting resources when you're done with them, because it's a cost issue. Well, this is critical because you want to not have to hunt around to find all the things that you created. You want to be able to, when you go to delete it all in one shot. And by doing what we're doing here, which is setting up a resource group first, then when we create the resources, we're going to put those resources into this resource group. And the resource group is called CNA-DevOps-03-RG. Now, when it comes to deleting everything, all I have to do is delete that resource group and all the resources inside of it go away. As opposed to if I had, let's say, 10 resources inside of there, we're not going to create that many, but if I did, then I would have to go and hunt around for all 10 individually and delete them all manually. And that's much more of a pain. And it's also more error prone. You're more likely to miss one or two of them and then have stuff laying around in your subscription that's incurring you cost when you're not using it. All right, so that's what we're doing with this step right here. So along the way, not only am I demoing this, I want to at least tell you the motivation behind what these steps are. Because I know if you just march through this and you're just copying this and pasting it there, it's very easy to, again, lose sight of that big picture. If you want to see the list of names of Azure regions, by the way, you can run this command right here. I'm not going to bother to do that. I'll leave it up to you to do it. But if you're curious about, well, what regions are available, that will tell you. Okay, next up, we want to deploy an AKS cluster using a GitHub workflow. So this is finally now where we get into that GitHub workflow bit, and that takes us right back to the GitHub page that I was on, which is over here. Right, we set up our action secrets. Now I want to go to there, to the CNA DevOps bit, and we're going to start following the instructions from here. So let's see, am I in the right place? CNA DevOps, that looks good. Quick setup. Okay, so what I want to do is first on the code tab, select add file, and in the drop-down menu, create new file. So we're going to do that. Code. And I want to do an add file. Let's see. This is telling me if I've already done this kind of thing before. I don't really want that. I want it to take me to a straight add file. I don't want to clone. Where is my ability to do an add file within here? It's a little bit strange. Quick setup. I don't want that. Oh, there we go. Creating a new file. It's kind of buried, unfortunately. Here's the case. They were trying to be helpful, and it's actually a detriment. What I really want is just that creating a new file link, and it got buried amongst everything else. There we go. Now I'm in the right place. All right. And the file I'm looking to create here, I want to name it this, armtemplates/akstemplate.json. So I'm going to copy that. This will create a folder within here called ARM templates, and the actual file is going to be called akstemplate.json. All right, then in the edit new file text box, paste the following content. So I'm going to copy all of this. Let me paste it in. I'm not going to obviously have time to go over what all of this is, but I can at least give you the general highlights of what is here. So what this is, I'll scroll up to the top a little bit like that so you can see it. This is basically setting up, it's an ARM template that sets up an AKS cluster, right? Remember, the goal of this was to configure an AKS cluster in an automated way, and this is the script that does that automation that you're seeing right now. Right. Again, the details of this would involve a lot of knowledge of both ARM templates and AKS and Kubernetes. And in order to really understand Kubernetes, you got to understand something about containerization, which usually means Docker. Obviously, I don't have time to cover all of that in an hour or an hour and a half talk. But at a high level, main thing you need to know, this is an automated way of creating what we're shooting for. Right. That's the biggest part of this you need to know. Okay, so that's the whole script right there. I do not need to change anything in that script, so that's all fine. At the end of the code tab, select commit new file. So that's the very end. You got to scroll down to the bottom here and just do a commit new file like that. And basically what we just did, we created a repo. We set up the secrets so that it can access our Azure subscription. And then we just have put our first file into the repo, which is that ARM template. That's the one-sentence summary of what we've done so far. So now within the GitHub repo, this is finally where we get to GitHub Actions. We're going to click on the Actions tab header right there. That's where we go next. And this takes us to where we get started with these GitHub Actions. And, oh, sorry about this little Lenovo annoying pop-up. And in the Get Started with GitHub Actions page, you want to select Set Up This Workflow. So that's what I'm looking for right there. Set up a workflow yourself. Oh, actually, no, that's not what I want. Oh, by the way, this is one spot where you may want to deviate a little bit from what the instructions are exactly saying. They're saying on the Get Started with Azure with GitHub Actions page, select Set Up This Workflow. Well, there's a Set Up a Workflow Yourself link, which you can go here. That's one way. All right. Another way, though, is you can come over to here on Choose Simple Workflow. All right. Either one of these two should get you to the same place. I'm going to deviate a little bit. I'm going to choose Simple Workflow and click on Configure. This will start with the file with the minimum necessary structure. And the reason why I'm doing this is that I'm going to replace all the contents with what's down below anyway. So it doesn't really matter, right? I could start with the simple one. And since I'm not going to modify theirs, I'm going to put in my own content, which is right here. That's why it really doesn't matter. Okay. And just to make sure I'm not missing a step in the instructions, it says replace the existing template with the following content while ensuring, and this is the YAML. This is the YAML I'm talking about, and it does say it here, while ensuring that you preserve the existing indentations. Now you've got to replace, be very careful to replace this section right here with your subscription ID that you recorded from the bash shell. All right, so let me get it in, and then I'll do it for my own subscription. Oops. All of this goes away, gets replaced with what we just brought in. a moment ago. And then I preserved my ID, which is here. I'm just going to place that into the appropriate subscription ID spot over here. And again, do not mess with the indentation. That is key. All right, let me check something else down below to make sure that this is not one that's problematic in terms of a version being out of date. I think it's in the next, no, this one does have the problem. Remember I was telling you that the lab instructions are generally up to date with one exception right here. The Kubernetes version, if you try running this, you're going to get an error. So you need to change this to 1.23.5 for this version number. And having done that, then you're fine. Okay, so that's the one caveat. Running that lab blindly is going to cause you a problem, just blindly following the instructions. So make sure that you do what I mentioned there. Okay, next up is, I think we're almost there in terms of being able to get close to trying it out. On the beginning of the page, select start. I'm going to make sure I didn't miss anything else. Just let me scroll up. The workflow dispatch event will allow you to launch the workflow manually. On the beginning of the page, select start commit. Okay, we're going to do that right now. That's over here, start commit. And that takes you to here. In the commit changes pop-up window, select commit new file. And on the actions tab in the list of workflows, select deploy AKS entry. So we're going to commit the file. So that will commit the change. And now we have set up what we need there. And on the actions tab, let's go there. Actions tab again. And right here is a deploy AKS that appears below the list of all workflows, because now we've set up a workflow. I'm going to click on that as indicated, right? So select the deploy AKS entry, and from the list of workflow runs, there is no current workflow run, but I can run my workflow by pulling this down and then choosing run workflow right there. Let me make sure that, just to double check that I'm not missing a step. Now that looks good. Also, you might want to check along the way to make sure that you are following what the screenshot shows. So I'm going to click on run workflow, and we should see in a moment. Let's see here. The workflow has no orange. There we go. Takes a second. We can see that there is a workflow there, and you could check the run status as it goes along by clicking deploy AKS, where it says deploy AKS. You'll see right now, all we've got is just one item in the workflow, just for deployment, right? And if you want to monitor the progress of this is the one that's going to take a few minutes, but I'll show you how you can monitor its progress. You can click on where it says deploy AKS cluster, and you can see what it's doing at a given point in time. So in fact, if you want to now, these are the major steps. If you want to now drill into one of these steps, like set up the job, then you can get the details of exactly where it is. So we can see what it's done. It's downloaded. It's the action repository. Let's go on to the next one and see where it's at here. And then if there are errors, you'll see exactly the spot where the error is. In fact, I can tell right now it's at the portion where it's creating the AKS cluster. So logging into Azure, I didn't get any errors there. So that's a good sign. Login successful at the end. And right now, this is the really time-consuming step. All right. So this is the one that could take several minutes. I'm going to let that cook in the background. In the meantime, are there any questions?
Yes. The question is, does Docker image contain the source code of our project?
Yeah, the Docker image will bundle up everything that you want to ultimately containerize. And that's one of the big points behind Docker. In fact, since I kind of promised to do this, and a few of you said that you have minimal or no experience with Docker, let me do a mini lecture while we're waiting on that. With Docker and Kubernetes. All right. I'm going to pull this from my course that I wrote on this topic. And I'll just do a few of the intro slides on Docker while we're waiting. This is, like I said, a good opportunity given the fact that I've got these periods of dead time where I just got to wait for the deployment to finish to show you the punchline of it all. So I'm just going to do the first few slides. It's like, what is Docker? What's containers? Just a little bit of that. So here's what Docker is about. It's an open platform for managing applications. And it's really about helping with the process of development, shipping, and execution. It separates application from infrastructure, but you manage both the same way. And it minimizes time between deployment and production. This is a big point behind Docker. It also provides efficiency and predictability to the development lifecycle. And it supports desktop and cloud. One of the big appeals of using containerization, by the way, next slide, about containers, is the fact that it not only removes the operating system dependencies, right, and platform dependencies that I was mentioning, but also here's a big appeal of using these technologies. You can work with on-prem and the cloud in exactly the same way, right? Normally, you have to do things a lot differently between cloud and on-prem. But if you containerize first, because you're now effectively removing dependencies that you have on the operating system and the platform and the cloud vendor, that means you have the ultimate in portability. You can basically take your containerized application and deploy it on-prem. You can deploy it in Azure. You can deploy it in AWS. You can deploy it in Google Cloud or IBM's cloud. It doesn't really matter because the basic container is going to work the same way. Now, the details of how you do that deployment are going to be different. But once you containerize, you can basically lift and shift that container wherever. And that's a big point behind containerization in general. Now, I got to draw a distinction between containers and Docker. Docker, this is a little bit like tissues and Kleenex. Here's the analogy, right? People often say Kleenex, which is a brand, when they mean to talk about tissues, which is the more generic term for what a Kleenex is, right? Same thing with this. Docker is one way to do containerization, but it's not the only way. There are some other containers that are less well-known, containerization systems that are less well-known, but Docker is the big name in this space. But the more generic term is containers. And what a container represents, and this is the answer to the question that was literally asked a moment ago, is a container is an environment for packaging and running an application. It contains everything necessary for the execution of that app. And it's not dependent on what's installed on the host. That's key, as I've been telling you. The container becomes the unit of distribution and testing. It acts as an isolation and security boundary effectively, and its life cycle is managed by Docker. All right? And here are the benefits of containers. This is about as far into Docker as I want to go, and then I'm going to show you Docker Hub to give you an idea of how ubiquitous this is. So the benefits of containers are standardization. You can develop with local containers. CI/CD, exactly what we're talking about in this session. You can share code through containers, and that's literally one of the big things that I'm going to show you right after I finish this slide. I have already talked about how important portability is, right? In fact, this is a big debate I was having with a friend of mine who's really big into microservices. And when I told him I was doing a lot of work on Docker and Kubernetes, his immediate reaction was, why are you wasting time on that? Developers don't need to know that. They can do microservices, but he's working on AWS and using Lambdas. And I told him, well, that's fine if that's all you're doing. But if you want to deploy on-prem and in cloud, you want to be able to work with multiple cloud vendors, you can't do that easily. You can't just take your code and lift and shift it over to some other deployment scenario. But if you containerize first, you can, right? Scaling. You can scale up or down in near real time, and it's very lightweight. It's much cheaper than using a VM. Be aware, containers are not VMs. And the big difference is, and I can show you a picture for it really quickly. I'm just selectively picking a few slides out of my deck here to show you this. The difference between a container and a VM is how much lighter weight the container is versus the VM. And there's one particular picture that I want to show that really, I didn't create this picture, by the way. I have a link to the bottom of the page where this comes from. This is an excellent picture. It shows you what a container really is versus a VM. With multiple VMs running on a machine through something like hypervisor, let's say on Windows, then you have to separately install the operating system into each one. Notice through containerization, you don't do that. All of the containers that are running on that machine share the same single installation of the OS. And that's what makes containers so much cheaper and lighter weight. Okay, let me see if my deployment here is done yet and completed. We're going to examine that. Let's go and look at the complete job and expand it out and see. Cleaning up orphan process. Almost done. Oh, no, it's done. I can tell by the green check mark there. Before I get to that, let me just finish up one more thought on Docker and just show you Docker Hub.
We do have another question after you're done.
Yep. I'll take that question right now while I bring up Docker Hub.
Perfect. It says, why would someone want to deploy using multiple servers as opposed to sticking to just one?
It really depends on the scenario. If you are working, well, okay, there's two issues. One would be multiple servers The reason to do that, of course, are things like fault tolerance. So if one particular server, if you're talking server machines, I'm not quite sure the context of the question, but I'll answer it two different ways. If you're talking about multiple server machines, the reason to do that would be things like load balancing, because if you only had one server, the problem is, what if that server got overloaded? Also issues like fault tolerance. If that machine goes down, then, you know, the whole server is gone. So obviously you want to have multiple server machines. Now, in terms of why would you want to have both on-prem and cloud installations, or maybe multiple clouds? Multiple clouds is probably a little bit less common, although I have encountered companies that I've worked for that have worked with, I should say, since I'm a consultant, that I've noticed have actually been working with both Azure and AWS. So I have seen that. It's rare, but I've seen it. But the on-prem and cloud scenario is actually not uncommon in a lot of companies that I've seen. And the reason for that is that what often happens is companies have on-prem installations. They realize now the modern way, more and more modern way to do things is to get up into the cloud, but they can't necessarily take everything from on-prem and immediately put it up into the cloud. So imagine that you are able to run your apps on-prem right now, and then to slowly start to migrate everything to the cloud rather than having to do it all at once. So by containerizing your apps, then you have the benefit of you can keep running it on-prem just as you are now, but with the exception of you containerize and maybe use Kubernetes to orchestrate the containers. And then now when you get ready to go to the cloud, it's pretty easy. You can do what we're doing right now, which is to set up an AKS cluster and just configure your containers right into that AKS cluster. And I can show you how literally easy it is to do that in the last demo that I'll plan to do. Okay. So that's the answer to why you might want to do that. I'm realizing when I go to Docker Hub, it's going to have me log in, and I think I have my login cached in the Chrome browser. So I'm going to go to Chrome. We'll see. And it's been a long time. Maybe I don't have a valid cookie anymore, but I'm going to check. That way I won't have to waste time logging in. No, okay, it's not cached. I'll just go ahead and sign in. I think I remember. I may not even remember off the top of my head my credential info. Let me see. I may have to go and look that up, in which case you guys may need to do this on your own. Let's see. I think that's right. No. Let me try this. I don't log in all that often. That's the problem. Not often enough. Just often enough to where I sometimes have trouble remembering what credentials I use for what. But let me try this one. See if I got that right. Hopefully that's the right credentials. I think I did. There we go. I just wanted to show you very briefly a big reason to look at using Docker or containerization, but especially Docker, because you have this, because you have Docker Hub. And Docker Hub, remember I was telling you that containerization is so popular that you will find just about all the big names in computing technologies are using this. So for example, by the way, I just went to the search box up at the top. I didn't put any search term in so I can see everything. I want you to see that there are over 9 million containers up on Docker Hub. This is a way for you to share your containers with other people. So basically what's happened is, for example, Ubuntu. They've containerized Ubuntu. Alpine, which is another form of Linux, very lightweight Linux. By the way, that's great if you were looking for a really lightweight Linux for a quick demo. You don't need all the bells and whistles. Alpine's great for that, incidentally. I use that, in fact, in the Docker and Kubernetes class because it's exactly what I want. Node.js. In fact, if I have time, which is on the borderline, the third demo, at least I'll start the demo. I don't know I'll have time to complete it. But this one is one that I could use. A Node.js implementation that's already Dockerized. Python is there. I mean, all these, I'll just leave it up to you to flip through. Nginx, that one I use. In fact, I use that for all the labs in the Docker Kubernetes course that I do. They're all based around this Nginx image that you see there, right? But I just want to give you some sense of, these are all names that I'm guessing you recognize, MongoDB, that you recognize. This is how ubiquitous containers are. The fact that it's not just about building and deploying, it's also about sharing. And Docker Hub is the means with which these container images can be shared. So that hopefully gives you, if you're brand new to Docker, a little bit more info about what it's about. And then now, what about Kubernetes? Well, okay, so you've got these containers. The next level is orchestrating them somehow. doing things like load balancing and going out there to deploy them. And that's where the Kubernetes part comes in. I'll talk about that a little bit more in the next bit of dead time, right? But I want to show you this now. We've got this deployed. I'm going to click on that deploy AKS cluster. You can see all the details of how it's successfully ran. I'm going to go back to the exercise instructions now that finished, and it indicates wait for the deployment to complete. It does warn you that it's going to take about 5 minutes, so that's why I was able to do that sub-lecture. And now we're going to go back to the resource up in the Azure portal, all right? Because the last thing we got to do is we got to see that it did something and that we can run it. So I'm going to get out of the Cloud Shell and find the resource group that we created. I'll list the resource groups. It was CNA DevOps 03, like that. And here's what got created from the run. The CNA DevOps 03 AKS. All right. What this is a web application, actually. I didn't write any code, of course. That was all there from the scripts that got created, everything in this deployment. And there's one thing I want to do is go to services and ingresses, like this. And I'm looking, this one doesn't have the external IP. This just allows you to see that the resource gets created. It's the next lab where I can actually show you running the app and then making a change to it, which I do want to get started as soon as possible because I know I've got another 5 minute or so dead period there. All right. But all this is doing for right now is showing you, yes, we were able to, through GitHub Actions specifically, create a resource up in Azure using a script. That's the point behind this first of the 2 labs that follow one another. And then after that, it tells you to delete the resources. Let me show you how to do that because I'm going to delete what I just created and recreate it in the next lab, which I'm going to have to press the time a little bit to have enough time to do, but I think we can get it in. Okay, so I'm going to go back to the resource group here. And here's how you delete all the resources in a resource group in one shot. And there's only one in here, but imagine that there were a number. You just click on delete resource group. And then you need to, this is very careful, so you don't accidentally delete it. You have to specify the name of the resource group before it enables the delete button. Now I click on delete and everything inside of that resource group goes away. All right. I know in this example, it's a little bit artificial because there's not that many resources, but if there were, then there would be a lot more convenience to deleting the resource group as opposed to doing them individually. Okay, let's get to the next part of what I want to show, because the real benefit of what we're doing will become visible to you when you see the next exercise we're going to do. I need to find the slide I was on here, which was this one. Okay, that's where I left off. So we did this. We used the ARM template. We deployed an AKS cluster. Now we're going to look at this next part, which is finally where I'm going to be able to create a pipeline where I can do what I said we were going to set out to do at the beginning, which is to make it so that we have a repo. I make a change to the code in the repo. Automatically, it rebuilds and redeploys, and we can see the change when we run the application. So just a little bit of background information before I launch into the next demo. CI/CD solutions enable separate deployments across multiple environments, which gives you consistency. Your developers author new features in their own environment, and the code is committed to a designated branch of the code repo via a CI pipeline. This is where what the developer does comes into play. And then what we want to have is the commit. So the developer makes a change. They do a commit in Git that triggers a build that transforms the code into a binary artifact that automatically builds, runs whatever tests you want to run, and packages up the application. And the release picks up that binary artifact, applies the external application and environment configuration information, and then produces an immutable release. That's what we're looking to do. And this is deployed to the specified environment implemented with some form of a CD pipeline. And that's what I'm going to demo to you coming up. So if you want to implement this, which we're going to do with CI/CD with GitHub Actions, cloud native apps in particular are suitable for containerization. And it enhances agility. That's that portability agility thing that I was just going over. This has a very close tie with Azure Containerization Services. In other words, ACR. ACR, just so you know, because it sounds like a number of you are new to Docker, you need some form of a registry for being able to store images, Docker images. In Azure, there's an entity that you can create called the ACR. It's a container registry for container images specific to Azure, right? You can store anything in there, but it's Azure's registry, basically. And then there's Azure has its own Kubernetes service, AKS. By the way, AWS has their own as well, EKS. So both of the major cloud vendors, of course, tend to offer the same things, and they both have Kubernetes services. That should give you an idea of how popular Docker and Kubernetes are. GitHub Actions include Azure support for provisioning resources with ARM templates. So I just demoed that to you. Running the Azure CLI commands, I demoed that as well, and applying Azure policy, which is what we're going to be looking at next. Let's do this next one. This is the big one. We're going to implement a CI/CD pipeline using the Azure DevOps Starter. We're going to do this in the Azure portal, actually, this bit of it, creating the Azure DevOps Starter. We'll use GitHub Actions. There's a sample that they have that's contained in a Node.js app that's going to be deployed into the AKS cluster, and we'll validate the CI/CD functionality by doing exactly what I've been hinting at that I would do, which is make a change to the code. We're going to see that that change results in a commit. That commit results in running the pipeline again, which results in a rebuild and a redeployment. So let me go right here to the instructions for this section, and we'll get going on this. I'm gonna leave that open. I want that open. Okay. Hopefully I have enough time. Yeah, I got enough time. About 20 minutes, right on the line for being able to do this. And during the dead time of this one, I'll kick off the third demo, and that'll be just about right, I think, in terms of time. All right, so in this exercise, here's the prerequisites. We know we have all those met. I'm going to skip over that in the interest of time. All right, before if you need to start with the web browser, go to the Azure portal and sign into the sub. I've done that already. In the Azure portal, open this bash shell. Okay, I need to do that again. You know, I've done that already, but I'm going to do that again. I don't have it up right now. I thought I left that. Oh, it's over here. This browser, right here. I'll get into the bash shell there, back into the bash shell, I should say. And then we'll follow the steps that they tell me to do. And that is this first. Within the bash shell session in the Azure Cloud pane, run the following command to register Microsoft Alerts Management Resource Provider. All right, so I'm just going to do that. Right click, paste after copying, and that registers that namespace. That's all we're doing there is just registering the namespace for that. Run the following command to verify what we did, basically. So I'm going to do that. Paste that in. So that just queries that it's registered. And that's just a double check. That last command that we ran is to determine that the alert management namespace is registered. All right. And it says wait till it's registered, but we saw that it was. Now we're going to do this part. Implement the CI/CD pipeline by using the Azure DevOps Starter. So it says in the web browser displaying the Azure portal. That's where I am right now, right over here. We are going to create a new resource, which is called the DevOps Starter. So I'm going to go and create that. Create a resource. The easiest way to find it is to search for DevOps Starter. And should be able to find it from that search. This is what I want to create right here. I'm going to click create. And then notice all the choices that you have for getting started with DevOps. All right. And it mentions here that now you got to follow these instructions very carefully because it's very easy to miss the piece that you need. For this one, it's actually a little bit less critical, but note that it says setting up DevOps Starter with GitHub, change the settings here. There is a link for that in one of the later labs. This is part of a whole sequence of labs, by the way. You'll actually need to click there. But for what I need to do, because it shows up initially, it's fine for me to just choose Node.js, which is what it's telling me to do right now. So we're going to use an example of a Node.js app. All right, so I'm going to click on Next. And for the framework, here I want to choose Express. And that's what you see on the next screenshot right there. And so I'm going to do that. All right. Next for the service. And then right here, it says on the select an Azure service to deploy the application page. Well, you know what we're shooting to do, a Kubernetes service. So you see how it's got a sample Node.js app, like walking through the sequence. It's using Express, and it's going to deploy it into an Azure Kubernetes service. And that is about all I need there. I think that from there, I just click on create, just double checking. And then I have to do a couple other things too for authentication. There we go. For authorization, I should say. On the select repository and subscription page, select the authorize button. So I need to just do what they tell me and select it. Little window pops up. And then in here, I've got to fill in the right bits that it tells me to do next. So on the authorized page, well, we did this already. I didn't have to do this authorize GitHub Actions bit because of the fact that I believe it's cached for me, having done it before. and it prompted to confirm access. Now I don't have to do the password or anything. It's all cached. Back on the select repository and subscription page, specify the following settings. Organization, the name of the GitHub account you'll be using for this exercise. So for organization, that's fine. That's the same one for my GitHub account. For the repository name, I need to put this in. So I'm going to stick that in for the repository name. Subscription, I'm going to leave as is. Create new for the cluster, leave that as is. For the cluster name, I'm going to choose this right there. That may be taken, by the way. You may need to change that cluster name because this, I believe, has to be unique. We'll see if it complains at some point. If it does, then I may have to make a change there. And then the location, once again, the same rules apply regarding the location that I had mentioned earlier. I'm going to stay with the default. It doesn't matter for me, but keep in mind the best practices that I told you earlier. Keep in mind now what Kubernetes is going to be doing. It's going to be using virtual machines behind the scenes. It's going to be running your containers inside of servers, but as VMs, and you can choose the size of the virtual machine initially. And if you don't like this one, you can click on change size to see the options. I don't really care for this demo. I just want to get something up and running quickly, so I'm not going to change these defaults, but notice that in real world scenarios, you probably want to tailor it to your needs. Okay, I'm going to click review and create just to double check that I didn't miss anything. Node virtual machine sets. I'm going to leave all that as the defaults. And then we're just going to do a review and create with all of that in place. I'm going to actually change this now that I look at the screenshot. I'll use South Central US because I was using that elsewhere. And I think that does make a bit more sense right there. South Central US. Okay. And then I'll do a review and create there. Again, I'm trying to pick the most lightly loaded data center as a priority over, oh, I have something. Following input, additional settings. Oh, yeah, I've got to click on additional settings. Forgot about that. And right here, let's see. This is the resource group name. South Central US is fine. That all looks good. And what didn't it? Yeah, I thought so. The registry name. Or the resource group name. Let's see. The following input values are not valid. Click on additional. So container registry name already in use. I thought so. Okay, so this was fine. I didn't need to do additional settings. It was that name that it didn't like. And the story is this name's got to be unique in all of Azure. So I'm going to just put in Reactor dash. Well, let me do a dash. No, I have to use alphanumeric character. So I'm just going to put Reactor on the front end of the name. This has to be unique in all of Azure, by the way. Anybody else containing a container registry, your name cannot clash with theirs, which is why I'm having the problem, because somebody else already took that name. And given that this lab instruction page, a lot of people are probably running it, there's a very high likelihood you're going to get that name clash. All right. So now we kick this off. This will probably take a while, actually. Let me go back to the instructions now over here and see if there's any steps that I can do while we're waiting. On the additional settings blade review, I did all of that. And then we reviewed and create. Wait for it to complete, and it mentions it might take this. Yeah, this won't be too long, maybe about a minute. And then open another tab, and I need to get back to GitHub, sign in using my GitHub account. Okay, we've already done all that. And let's see what the next bit that we need to do on the GitHub side is. And then we're going to go back to the actions in GitHub. Okay, deployment's complete. That looks good. Now, this requires a little bit of tricky manipulation. So I want to go back to here, go back to there. All right. And let's see, on the Actions tab, on the CNA DevOps 5 repository page, click the Actions tab. Let's see, we have not created, I think I missed that step up above. I believe I was supposed to have created first a CNA 5 DevOps, a CNA DevOps 5. Let me look for that. CNA-DevOps. There should be a page for it already. This is created. What am I saying? Okay. I just need to find that in my sub. And there it is. See how that got created as a result of what we just did. So now I'm just going to go there to the CNA DevOps 5 that was created from what we did in the Azure portal. Remember, you never saw me create that manually. That got created automatically. All right, let's come back further down and then see the next set of steps. And we've got a repo now, right? That's the important thing. From the Actions tab, let me sync up to where we were. Okay, so we were just there, back on the here we go. Back on the select repository and subscription page, select review and create. I did that. Open another tab in the same web browser. Go to GitHub, sign in from the GitHub page, go to the list of repositories, find CNA DevOps. So we just did that. On the CNA DevOps repository page, select the Actions tab. Step 17 is where I am. So Actions tab. All right, and you've seen this before. On the Actions tab, list of workflow runs, select the ellipsis. This is a little bit different though. The ellipsis next to adding workflow entry, and then in the pop-up menu, select cancel run. So there is a run right here. They want you to cancel it. So I'm going to cancel it. The reason for that is there's something you need to patch up a little bit. So I just did what they told me to do there. There was a run going on right out of the box. It told me to cancel it. I canceled it. And then it says from the Actions tab on the CNA DevOps 5 repository page, select the code tab. That's here. So we're going to go there. On the code tab, select the GitHub workflows folder. This is a little bit of thing you got to touch up. And then let me make sure I'm synced up. DevOps starter workflow.yaml entry right here. The change you need to make is you've got to edit this file, and it tells you what change to make down below. In the edit pane, scroll down to this entry where it uses Azure ARM deploy v1. You need to change that to ARM deploy main. All right. And the lab manual explains some of the more intricate details of why you need to make this change, but which I don't want to spend a lot of time on given that I'm a bit pressed for time. So I'm just going to tell you, yeah, if you do this lab, you got to come in and make this change. Cancel the build that they were doing and make the change that they're telling you, which is on that line right there. Uses deploy. Let me make sure I got it right. ARM1. Yeah, instead of V1, I'm going to set that to main. There. Okay. But I don't want to screw this up and then have to try to debug it later, given how pressed for time I am. I'm going to start the commit and commit the changes, and then we are good to go. And I think now we're in the dead time zone again because, let's see, and switch back. No, okay, I have to do this. Switch back to the web browser tab, displaying the Azure portal, and on the development page, select go to resource. So here, I'm on this go to resource part. And I remember I do have to do a couple of steps here, which is to authorize permissions, right? That's what it's telling you. And on the GitHub authorization task, select authorize again and authorize another time. And this now authorizes the GitHub account appropriately. And then you can actually see the GitHub workflow here. And let's see if, let's check the status. It looks like there was a failure, but that I don't know whether that was the old one or whether it was the latest one. I think I know what this is. Let me check the error specifically. And if it is what I think it is, I know exactly the remedy, which is I just need to run it again. If you look, see, this is how you debug it. Deployment failed. It says unable to edit or replace deployment. Preview, that's previous deployment. Previous deployment is still active. I've seen that before. It's exactly the error I thought. The problem is, even though we canceled it, there's a bit of a lag. So about all I can do is wait and rerun it, right? Which gives me an opportunity to show you how to rerun it. I don't believe there's anything wrong with what I did, but like I said, literally I've seen this happen a few times before, but here's how you can rerun it. I would wait a little bit before doing that. You can come back in and choose rerun jobs and say rerun failed jobs. And usually after I rerun it with a little bit of a delay, then it's good. So let me go ahead and try that right now. And then once again, you can monitor the status. But notice, remember before we had this, we had this build and push. We had the build step before in the previous demo. But notice the new thing, the deployment part. This is the whole idea of the CI/CD. We've now set up a pipeline that not just builds and pushes the images, but also deploys it out there so that we can actually try running the AKS resource. Let me see if it gets at least far enough in, farther than it did last time, before I go off and do something else. I just want to monitor the status to see that it gets farther than it did on the last run. Typically, second run, I'm usually good, as long as I don't do the second run too quickly after the first run. All right, creating deployment. Let me zoom in and get a little more info if I can. No, it's not there yet. Okay. Well, in any case, I don't like to sit here blindly staring at that. I'm going to go ahead and set up the third demo now, because since I am pressed for time, and I want to show you, and the third demo is quick, so I'm going to go ahead and go back to my slide deck for a moment while that one's cooking in the background. And then I'm going to show you this, which is finally the DevOps pipeline. Azure DevOps Pipeline. I'm not seeing my cursor show up. There we go. And this way I can get back into full screen. I want to say a few words about Azure DevOps, and I'll launch into that last demo. So this is what we want to do. We want to create an Azure DevOps project, create a pipeline to provide CI/CD for AKS. So we're going to do basically the same demo I just did, but we're going to do it with Azure DevOps. And we're going to configure GitHub as the code source, configure ACR and ACR as the repository, which I'm going to manually create. We're going to configure to deploy to AKS, and we're going to run the pipeline, exact same thing I'm doing with this last demo, test the deployment. The CI/CD part is we're going to change something in the Docker GitHub and then retest the deployment and verify that everything still works, right? Here are the prerequisites that you need. I have all those prerequisites, but there they are on the slides. This is a set of screenshots I put into this slide deck to show you the process. All right, now let me show you what I already have set up. I'm going to check the status of this as I go. That's good. It hasn't failed yet, and it appears to be getting farther than last time. So that's a good sign. Yeah, I think this is going to be good now, because by the nature of the error, I think we solved the problem, which is just try it again, because the cancellation didn't take and I ran it a little too soon. Okay, next up is I already have in my Azure repo, GitHub repo. I got to use the right terms. GitHub repo. I already have this, which is a simple Node.js application. All right. Not there. GitHub. I'm going to open up a separate GitHub browser tab so I don't interfere with the one currently running. And then this is the exact one I want to go to. All this is very simple. In fact, let me show you the clone of it I have on the local machine. And I'll launch Visual Studio Code so you can see it. All it is a Node.js Hello World application that I created. Simple as that. All right. And I'll show you how I got to where it's up in my GitHub repo. So this is a sample from the internet, literally. It's just a Hello World Node.js app, and I basically took the code for it and Dockerized it. Right? So this is the application itself. It uses Express. In fact, let me take you to the package.json first. It uses Express, and right there, there's a dependency on Express. And then here's the actual code in the server.js. Brings in the Express library, and then just sets up the server to send, no matter what the request is, it sends the hello world string and then indicates out to the console that what port it's listing on. And then back over here is the Docker file. The Docker file, by the way, if you're new to Docker, Docker file contains a set of instructions for what's necessary to containerize the app. And remember what goes in the container, everything necessary to run the application. So this is that set of instructions. And I'm not going to bore you with all the details of this, but I just wanted you to see what a Docker file looks like if you're brand new to this. Bottom line is this file has the instructions for packaging everything up for this hello world Node.js application. The Docker ignore is so that it doesn't put into the container the node modules folder, because that contains all the libraries and they can be regenerated automatically when in the Docker file you run npm install. Because we're going to run this, it regenerates the content of the node modules folder. So there's no point in putting it into the container itself. So that's why we put it in the docker ignore file. And then this instruction here does the same thing with the log files, because why put those into the container itself, right? So what I did is I first created this, then I went and pushed it up to my local repo here for a Node.js demo repo. All right. Now the question is, how do I get from that to an Azure DevOps pipeline around it? So this hopefully is giving you a feel of how you would start from nothing. The starting point would be hello world application for Node.js. Add the Docker file, the .docker ignore, run some commands to test it locally, which are beyond the scope of our discussion here. If they ever offer the Docker class at Microsoft publicly, then I'll be happy to tell you all the details of how to do that. But the main thing is I want to focus on the DevOps part right now. So once I have that up in and tested, then I push it up to the repo here. And now I'm going to show you how to make this work with DevOps. And it's really easy. Most of the work's going to be done for me by the DevOps infrastructure. Before I do that, let's go and check the status here and see if it's still working. I can tell. Still working on creating the cluster. But I do hope to show you that in the next few minutes, that at least it's running successfully and that I can make a change and it'll rerun everything automatically. Okay, but let me walk you through the steps here on this last demo of how to do the equivalent of what we did with the GitHub Actions, but to do it with Azure DevOps. Okay. So here's the screenshots. I want to just review how the process is going to work. I'm going to go to the DevOps in Azure and create a new project. So that would be this will get me into dev.azure.com and pick my appropriate account. All right. Yeah, that's fine. I think that was from a project that I deleted. So let me go right to here. Too much on the URL there. Right there. Here we go. Notice I have a couple of organizations set up. I want to use this one for a reason that I'm going to tell you about coming up, but that's the one I'm going to choose. I'm just going to create a new project inside of here. All right. For the project name, I'm going to call this DevOps demo, or I can call it anything I want. Doesn't matter. It's a very quick process. Choose private, click create. All right. And then now on the next step, I'm going to point it off to that repo where my hello Node.js resides. Normally, this doesn't take that long. Wouldn't you know? And the reason, oh, there we go. Good. Like I said, from past experience, I know that shouldn't take too long. All right, so I've created a project in Azure DevOps now. The next step is I'm going to create a pipeline. So I'll click on pipelines there and create my first pipeline. By the way, I'm just running ahead of the screenshots, but here we go. Here are the steps. But this is the big thing. Since I have the code up in GitHub now, when it says, where's your code? I can just point it right off to the GitHub repo that I've established. Right. This is like really, really easy, just a couple of clicks. Oh, one thing I'm going to need, by the way, I haven't created. I created one part of it. I created a separate AKS resource for this demo. I need to create the ACR. I need to create a registry. The registry creation is quick, but the creation of the AKS resource takes a while. So let me just go ahead and get that quick part in place. I created this last night knowing I was going to do this demo, and that the AKS, see this Kubernetes service I created? I did that one last night because that one takes about 5 minutes or so to fully provision. The next one I'm going to create is pretty quick to create. So that's why I'm going to do this one dynamically. I try to do stuff as dynamically as I can, but in some cases, it just takes so long, it's better for me to spin it up in advance. All right, I'm going to choose container registry here. Like I said, the container registry, think of it as similar to what I showed you with Docker Hub, except it's local to your Azure subscription. And of course, it doesn't have all the entries in there that Docker Hub has. All right, I'm going to put this into the same resource again so that when I go to delete it, that I'll be able to delete both the AKS and the ACR resource in one shot. I'm going to call this Reactor and ACR. Reactor ACR is good enough. I think that'll be unique. For location, I've been going with South Central US. I'm staying with that. And that is good. Review and take all the defaults otherwise and create. And once I have that, then I can go through this next wizard back where I was over here. Not there. I was here on the new pipeline. Okay, so I'm going to choose now the repository. Well, you saw what repository that was. That was the Node.js demo one right here. I'll select that. And then now I can indicate what I want to configure this to do. And I want to deploy that out to the AKS service that I was showing you that I pre-created last night. So when I come into this dialog to deploy the AKS service, and by the way, when you get my slides, I put the link at the beginning of the session to where you can download the slides. They have screenshots so you can go and replicate the entire process I'm doing right now. All right. I'm going to choose my subscription right there, continue. And then this is why I had to have the cluster created already. So when I pull down the dropdown, it populates with the one I need, the Reactor Demo Live AKS. Namespace existing, that's fine. I'm going to pull this down and choose the default namespace. And that's why I have to have the container registry created. That was the one I just created seconds ago. So I could, when I come to this dialog, populate the whole thing, and I'm good. Everything looks good here. I don't need to enable review. I just want to do it as quick and dirty as possible. And now it's configuring the pipeline, right? And this will take a little while, by the way. Just like the one I was running in the background is taking a while. This, well, it's going to do this. And then when I do the save and run, this is going to take a while. All right. And I'll click on save and run. And now our pipeline's set up with both a build and a deploy. And we've done the equivalent of what we did in the demo that I was working with in GitHub. In fact, let's go back to that GitHub demo and see if it's done yet. Oh, goodness, it's still creating the cluster. It's taken a while. Yeah. Oh, no, it's done. Okay, it just hadn't updated in the UI. It's done. Good, 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 good. I'm so happy. Okay, so I want to prove to you that this did something. So finally, we're going to go and run the application. I'm going to go back into the Azure portal. Forget about slides. Forget about the lab manual. I'm pressed for time. I'm going to do this off the top of my head. So we're going to go back into the Azure portal. We're going to find that AKS resource that got created, CNA DevOps 5 is what it should be. Find it from the resource group is the easiest way. It's another reason to use resource groups, because then I can also locate the appropriate resource more easily. Here's that AKS resource that got created, CNA DevOps 5 AKS, right? And here is how I can test it. You go to services and ingresses. This is how the application itself exposes the IP address publicly. Look in the external IP column. Right there is the IP address. I can just click on it. If I do, it's not going to take me to the right place, though, because this code that was brought in automatically is listening on port 8080. So I need to put 8080 on the back end, :8080, to hit port 8080 on there, and there you go. See? It's already not just built the AKS service. It's deployed it out there, and I'm proving to you right now that the deployment's successful. Okay, the last thing, and I doubt, unless you guys can hang around till 10 o'clock, another 25 or so minutes, because you have a little bit to run it, but at least I can show you the process being kicked off. What I'm going to do now is the final punchline of all of this, which is I'm going to go back and make a change to the HTML that you're seeing displayed here. You'll see that that change is automatically going to trigger a rebuild and a redeploy. And then ultimately, if I hit this after that process is done, you'll see something different in the web page. So rather than saying GitHub workflow has been successfully set up, we're going to change that to successfully updated. Okay, one change to one HTML file. We're trying to make this as simple as we possibly can get. So I'm going to go back to the repo now. Find under application. This is where the application files are. There's a views folder underneath there, and this is the index page that we're going to modify. This is the markup that's being displayed, all right, that you were seeing on that web page a second ago. Now I'm going to come in and find where it says right here, running successfully set up. I'm going to change that by clicking on the edit button right there and come back in and change it from successfully set up to successfully updated. So let me make sure I'm doing the right spot here. Clone your code and start developing. GitHub workflow has been successfully updated. That's what I'm going to say. Just one small change. That's good enough. Let's commit that change, which is at the bottom of the page. Commit changes like this. All right. And then we'll go and look. And right now, it should automatically be rerunning the build process again. Keep in mind, I didn't do anything special. Go back to actions again. There you go. See, it's automatically kicked off another workflow run, which represents the update. And it's rebuilding everything. Keep in mind, if I made it, let's assume for a moment this was a code change. Then if I had as part of this workflow unit tests, those unit tests would be automatically rerun. And then when this finishes, it's automatically going to redeploy. And if I come back to the web page we were just on a moment ago, we should see that change in this page, right? I don't know whether you guys want to hang around long enough to see it. If you do, I'm happy to stay around up until about 10 o'clock. But at least you see the process is being kicked off. Let me go back to the other demo I have running over here and see the build stage of this one succeeded. It is in the deployment stage. Oh, it's waiting on permission. So let me handle that. If I come over to here, it indicates that I need to approve it. So I have to click on view, click on permit, and then click on permit again to permit access. And now it'll move forward from there. So this is the other job I have running, very similar to the one that I have running for the current demo. The difference is this one's using Azure DevOps and the other one's using GitHub Actions. But they both are doing the same basic functionality. Hopefully this will run relatively quickly. on this deployment stage so I can at least show you this one up and running the same way that I did for the one over here, for the one with GitHub Actions. And that way you'll see an example of both of them and see how the two can accomplish basically the same end. All right. Let me move on in the slides to just kind of wrap up because I know I'm a little bit over time now. So these are just screenshots of the whole process that I went through for the demo with AKS deployments with Azure DevOps pipelines. Oh, I got to caution you about this, by the way. If you try this, if you try to go to my slides and replicate the demo that I just did, be really careful about something. Unless you've gone through the process once before and encountered this, you will get an error, a parallelism error. I have a screenshot of it. What the story of this is, this very important slide, and I don't want to gloss over this one, even though I am a bit over time. Azure Pipelines offers free CI/CD, 1,800 free minutes per month, 10 parallel jobs to open source projects. However, if you're new to this, a new organization does not necessarily get 1,800 free minutes. There's a blog post that I linked about it. This change was made because people started to abuse this. And for example, they were doing things like sending spam or mining Bitcoins using this automated mechanism. And so the intent was to make this free to the community, and it applies to public projects and certain private projects. So the change they made now is you have to request parallelism. Parallelism meaning those steps that you see being executed as part of the pipeline, those are being done in parallel, and they're not just going to allow people blindly the way they used to do this all free because it subjects them to people doing things like this. Of course, as with anything free, people tend to try to abuse it. Some people who are unscrupulous. So what you have to do, go to this website, apply with a parallelism request. And on paper, they say it takes about 2 to 3 business days for Microsoft to review it and approve it. It took me about 1 day. So fortunately, they tend to underpromise and overdeliver. But it could theoretically take you up to 2 to 3 business days. So that was why when I did that demo, if you remember, I chose very carefully the organization that I did as opposed to the other ones that were in the list down below, because I wanted to make sure that I chose the one for which I had been approved for parallelism. The other two that I have a couple of other organizations in my Azure DevOps subscription where I have not approved for parallelism. I've not even requested it. So that's why I had to make sure to choose the right one, or I would have gotten that parallelism error that you see here. So if you ever encounter that in trying to do what I'm doing with the DevOps demo, be aware, yeah, you're going to have to do a formal application. That's why when I teach this in the Docker and Kubernetes class, I have to tell everybody at the beginning of the week, hey, you guys are all going to have to apply if you want to do the equivalent of this very last piece that I'm doing right now. All right, I just ran the pipeline manually. This is what it will look like when it finishes. And then the way you go about testing it is you can do it exactly the same way, is to navigate back to the application. And actually, you can do this from the Azure portal. You can find out the external IP address from the Azure portal, from the DevOps portal, as opposed to going to the Azure portal. If this finishes in time, I'll go ahead and do that. It's still working, unfortunately. Let me go back to the other one that I have. I have 2 cooking right now. So let me see if the other one's done, which is this one. That one's still working as well. Well, unfortunately, I'm now at the stage where I'm waiting on 2 different demos to finish. But let me just go ahead and skip ahead to wrap this all up. And then I'll take questions. And then if any of them finish, whoever's left, it allows me to prove to you that all this stuff works. Couple of last things. One is obvious question. What about GitHub Actions? I showed you that. I showed you Azure Pipelines. Which one is quote unquote better? I can't say one is better, but I did put in a slide with a link on there. And the second link is the one to really look at. Recommendation table. Note this comes from the Microsoft Docs for common scenarios, which one they recommend you use. And in some cases, they'll say both. In some cases, they recommend Azure Pipelines. In some cases, they will recommend using GitHub Actions. But this page is comprehensive, like these cases, GitHub Actions. And if you want to look at the table they have for a feature comparison, look here. I was going to summarize this on a slide, but I said, why bother to do that? I can just point you to the page. You guys can go off and read it, and you can see much more detail than I can fit on 1 or 2 slides. All right, to wrap all this up, what we talked about in here is how Azure DevOps concepts and software best practices to cloud-native apps provide benefits in deployment, development, monitoring, management. And what all this does is it maximizes availability, stability, performance, and efficiency in delivering new features. And I've just got to go back and see if either one of these two finished. Like I warned you at the beginning of this that I've got some runs that take a while. That one's not done yet. And I've got a run. Let me, might be an update issue though. I'm going to come back around and just take a look. Because sometimes these do, now it's still on the deployment stage. And let me check the other one. Would have been nice for me to show you these finished products, but because they take so long to run, this one's still working too, sadly. All right, well, you guys can, oh no, it looks like that one may be actually done. If so, I can run it and at least show you this one, let me go back to the Actions tab. Yeah, oh, it's done, beautiful. All right, here we go. This is the culmination of everything now. I'm gonna just come back and refresh this page. And what I expect to see is the change showing up, which indicates, let me go ahead and F5 it. There we go. GitHub workflow has been successfully updated. So what that shows you is we set up an Azure, through GitHub Actions, we set it up so that we can now make a change to anything in the repo, have it automatically trigger a rebuild and a redeployment. And you just saw that it is up in production with that change. And what did I have to do as a developer? Just make the change. Once everything's configured with the GitHub Actions, all I have to do, make the change, and everything else happens automatically. That's what I wanted you to take away from this session. And I'm finally glad that we were able to show it at the very end. All right, I'll take questions for 10 minutes or so.
Okay, perfect. I have developed web apps using Docker containers like Azure Container Registry, and I have app settings I want to manage settings via Azure configurations. How do we do it?
Assuming you're talking about DevOps, exactly the last demo that I did. That was pretty much it. You have all the infrastructure, it sounds like, in place because you're using ACR already. It sounds like you're using AKS. You just walk through that exact same sequence that I did in this demo. Let me check if that demo's done yet because I'd really love to show you this one. Nah, it's still deploying. But you just do exactly what I have in the screenshots and the slides, and you can get there where you have an automated pipeline with an initial setup as simple as what I'm showing here.
Perfect. And the next question, and Docker question, what includes Docker image in itself?
What includes Docker image in itself?
Mm-hmm.
I don't really understand the question, frankly. Does that mean like containing Docker within Docker, or
maybe they can clarify?
Yeah, maybe even clarify the question because I really not sure what's being asked there.
Let's see the next question. So we have a comment saying good topic and demo. And then the next one is, I have access to Azure DevOps. How well does the tutorial translate to this platform? Or is there a tutorial that uses Azure DevOps?
There's a number of tutorials actually, and they do translate very well, very, very nicely. In fact, the slide deck and the demo I'm doing here, when I was first learning this, I used the tutorials as a means to figure it out myself. And then I just, really what I did was I went through their tutorials when I was first going through it. and they're very, very well done. Microsoft does an excellent job, I have to say, with the general walkthroughs, the tutorials that they have. And then I just mapped that on to everything else that I was showing in the Docker Kubernetes class. Just so you have some context, this demo I'm doing right now and these slides I put into the deck at the end about using this Azure DevOps pipelines is part of the last module of my Docker and Kubernetes class. And what I do before then is that same Node.js repo that I was showing you. I demo how to start from nothing and to use that as a way of taking like a Node.js app, first Dockerizing it, then putting it up into Kubernetes, and then showing you how, like in an on-prem sort of installation, that you would test it and run it. And then the culmination of everything is then I show how to do that with AKS, so that you don't have to manage all the clusters and everything that you would if you were doing this with like an on-prem Kubernetes installation. And then the last thing is DevOps pipeline, the very last thing. So the bottom line is it was very easy for me to adapt what I already had in the course to showing it with an Azure DevOps pipeline by looking at their tutorials. So yeah, bottom line is I would strongly recommend looking through this because they do a great job on them.
Yosef has 2 questions.
Okay.
Did I notice correctly that the GitHub repo created by Azure using the original name given for the trial that was changed for Azure was taken up?
Can you say it again? Sorry.
Oh. Did I notice correctly that the GitHub repo created by Azure using the original name given for the trial that was changed for Azure was taken up?
Yeah, that's correct. There's a lot of resources in Azure which have to be that you name that have to be unique in all of Azure, which means anybody else using that same resource, your name cannot clash with theirs. And that is not uncommon. In some cases, it's because the name you're giving represents an address, like an IP address. So given that, it has to be unique. By the way, I just noticed this deployment failed, and I've seen this before, and I know what the story is. It says exceeded its progress deadline. Basically, that's indicating that it timed out. From past experience, I need to just run it again. It's some internal thing. I've been noticing this is a little bit more frequent. It kind of depends on when I run it, or I don't know. But in any case, if I run it again, there's a high likelihood that it might be fine or not. But let me try rerunning the failed job. It won't complete in time before we end the session, but I've tried this before. I've seen that error before. Sometimes rerunning it will make it work, or not, depending on how loaded things are. I've just noticed that error a lot more recently, actually.
And the second question, also wondering why this Express page shows 90 visits when first created, then 180 after just one update.
Oh, if you're talking about my Express page, it's because I've done this a number of times. I just use that same repo over and over again. I'm assuming you were talking about my Node and Express page. Or were you talking about the more publicly available one? I'm not sure which one the question's referring to. Which demo and which Express page?
Maybe they can reference in the chat, but that was the final question. I'm just going to quickly hop on and ask everyone to fill out our survey. We'd love to hear what everyone would have to say. Please visit our survey link. The event code for this specific event is 15879. While we wait for anyone.
Yeah, one more thing too. I wanted to mention this. If you guys have a question, I know some of you, I'm asking for clarification because I'm not quite sure what you're asking. Here's my email address. Feel free to shoot me an email. And you can, I think it's at the beginning of the slides too. Let me see if I put it on.
Yosef said the second demo.
Oh, right there. Yeah, it is at the right at the beginning. So, feel free to shoot me an email if you want to follow up on the questions you're asking me. Because unfortunately, in this format, I'm not able to interact with you directly. I have to do a little bit more indirectly. But email is a fine way too if you do want to follow up with a question. All right. Anything else?
They said the second demo, and everyone else is saying really, really amazing presentation.
Oh, thank you.
Amazing session. Thank you all.
Yeah, thank you very much for that positive feedback. I enjoyed that. And thank you very much for attending. It was great having you guys. I love the fact that you're asking questions and being engaged.
Well, thank you, everyone. Until next time, have a great one.
All right, bye.